Okay, let's go over practice one from the complex circuits worksheet, or I think it says complex resistors maybe. But all we need to find for this is the equivalent resistance for the whole circuit and the current out here at the battery. So let's start with equivalent resistance. The first thing that I notice is that this set of 3 resistors are all in series. Even though there's like a corner here, that doesn't really make a difference. When current flows from the battery this way and it gets to this branch, some of it's going to go down, some of it's going to go this way. But once current gets into this branch, the only way it can go is just around this loop here, or around this bit. So all of these are on the same branch, which means they are all in series, which means all I need to do is add them together. The temptation, because of this picture, is to think that the 1 and the 4 are in parallel, but that's not true because these are in series first with that 4 ohm resistor. So let's add those 3 together because they're just in series. You just add them, and then I'm going to redraw the circuit. So we've got the 3-volt battery, this 1 ohm resistor we haven't handled yet, and now 2 and 3 is 5, so we got 9 ohms right here, which represents these 3 together. Now, simple. 1 ohm resistor, 9 ohm resistor, they are parallel to each other. We are simply going to do 1 over 1 plus 1 over 9. Okay, so that's the current, which is approximately 0.9 amps. Okay, so, or wait, no, that's equivalent resistance. Ah! Ohms. Ish. Okay, all right, so now we just need to find the current, and it's gonna be one of those days, I can just tell. So 3 over, I'll use that one. 3.3 ish amps. Okay, there we go. Let's do practice 2. All right, practice 2. This is again drawn strangely, but we're starting with things we know how to do. One thing I can see is 2 resistors in series. I'm going to add them together and redraw my circuit. This battery doesn't need to be here. I could draw it over here. I'm going to, because that's annoying, to me at least. So I add 1 and 2, and I get a 3 ohm resistor. And then I've still got this one. I'm getting a little smushed here, sorry. 3 ohms, and this one is 4 ohms. Now there's a temptation to say, aren't these in series? There's a junction right here. But what you do know is that this 3 and this 4 are in parallel. So I can do those next. So let's do 1 over 3 plus 1 over 4, which would be 4 over 12 plus 3 over 4, which would be 7. Oh, that's a 12. Over 12. And then we flip it, and we get 12 over 7. I'm going to leave that as a fraction because I have more to do. So let's redraw the circuit. There's my 3 ohm from here. And now I've combined these 2 to get this 12/7 ohm resistor. And now everything's in series. I can just add. So 3 plus 12 over 7. Okay, so our equivalent resistance, which I'll just write up here, ends up being 33 over 7, which is approximately 4.71. Okay, cool. So now we just need the current. What's the volt for? And again, you know. If you're not doing this, I hope you feel guilty. Okay, and we get exactly 28 out of 33, which is like 0.85. Good, one more. Okay, practice 3. First thing I see. These are in series. They're on the same branch. If current is going, I guess it'd be coming this way. It gets here, it splits, it goes this way. It has to come around this corner and go through both of them before it can do anything else. So these two are in series. 4 and 2 gives me 6. Let's redraw the circuit. So we've got, and again, this doesn't matter if the battery's here. I'm going to draw it differently because it's annoying. So this is 2 volts, 1 ohm, 5 ohms. This is still 3. And then now this is all together as 6 ohms. Okay, what do you see? I see this. These are in what? Parallel. Can't do anything with this yet. Can't do anything with this yet because we have this set of parallel branches in between. So we need to add these first. So I'm going to do, oh, that's a 6, which would be 2 over 6 plus 1 over 6, which would be 3 over 6, which when flipped would just be 2. Yeah, that's right. Okay, so this is 2 ohms. So let's redraw. And now, look, everything's in series. Just add it all up. So we got 5 and 2 is 7 and then 8. So our equivalent resistance is just 8 ohms. That's so nice. It worked out so nice, whole number for once. And now we just need the current, no big deal. So what's the 2? Ha! Or a quarter, whatever you want, same thing.